Okay, we're looking at some exercises on iteration in strings. Let's look at it one by one. Okay, so pause the video, read the instructions, then do the problem. Then after you think you've got a solution, look at my solution. Okay, you're back. I assume you've got some kind of a solution. Let's look at mine. We initialize the result to be the empty string, and then n times. This is what it means for I in range of n. Do this n times. Result is result plus string, and return result. And here are the tests. Okay, let's go on and look at the next problem. Okay, pause the video. Definitely pause the video. Read the instructions. Then after you've got a solution, start the video again. Okay, you're back. I assume you've got a solution. Let's take a look. So we set front length equal to 3, and the front length is greater than the length of the string. Then we make front length equal to the length of the string. And front then becomes the string ending one character before the current value of front length. Then we initialize the result to be the empty string, and then n times. Do result is result plus front. And here we have the tests. Front times of chocolate, comma 2. The first three characters are cho, cho, 3, cho, cho, cho. And then we have an example where the string didn't have a whole 3 characters, and this was taken care of by that first little piece of code at the beginning. Okay, so we get no, no. Okay, on to the next. Again, pause the video, then do the problem, then start the video again. Okay, you're back. I assume that means you solved the problem. We initialize the result to be the empty string. Then, for every character in the string, for I in range of len of string, this is the way you iterate through a string by index. And if the division of the index by 2 gives you a remainder of 0, that means that you're at an even index, and you add that particular, the thing in the string at that index to the result. And then you return the result. Here are the tests. H, L, and O. If you only had 1 or 2 characters, you only get the first one. And look at this thing, H. We take the H, skip the E, take the E, skip the O, take an L, skip an O, take an L, skip an E, take an O, and we get hello. Okay, next problem. Read the problem definition, solve the problem, and then, of course, restart the video. Okay, so you're back, so I assume that you've solved the problem. And here we initialize count to 0. And we have a list of numbers. So for num and nums, if the number is equal to 9, add 1 to count, return count. Here are the tests. We have 1 9 in this list. We have 2 9s in this list. And we have 1, 2, 3 9s in this list. Okay. Exercise 5. Again, read the instructions. Pause the video. Solve the problem, then restart the video. Okay, you're back. I assume you've solved the problem. First, we have to figure out where the end of the loop really is. End is len of nums. So if your list were only 2 elements long, then end would become 2. On the other hand, if the end is greater than 4, then the end becomes 4. So that'll always give us a good end of loop. So then, for I in range of end, if the ith element in the list is 9, return true. And of course, if you ever hit a true, then you never get to this return. So remember, when you hit a return, you exit from the loop completely. You exit from the function completely. Okay, on we go. The tests. Look good. There was no 9 in this first 4. There was a 9 in this first 2, so we get a true. Next problem. Return true if the sequence of numbers 1, 2, 3 appears in the array somewhere. Well, it does here. You can see the 1, 2, 3. It doesn't here, but it does here. Okay, so you understand what you have to do. So go ahead after pausing the video, solve the problem, then come back and look at my solution. You're back, so I assume you're ready to look at the solution. So the first thing you had to do is figure out how not to run off the end of the loop when you're indexing. So this prevents you from going off the end of the loop. And then you look at nums of I plus 1, nums of I plus 2, and see if you've got a solution where this is a 1, a 2, and a 3. If it is, you return true, and that takes you out of the function, so you never hit the return false statement. And here are the tests: true, false, and true. Okay. This is a complicated one. So read it very carefully, understand the instructions, and pause the video. Then after you've solved the problem, come back and look at my solution. Okay, you're back. I assume you want to look at the solution. You have to figure out which string is shorter. It doesn't really matter which of the two strings is shorter. What matters is that you don't loop past the end of either, you don't index past the end of either list. So for I in range of shorter minus 1, this stops you from running off the end of the list, because you're going to ask for I plus 2. Or you're going to ask for 1 less than I plus 2 when you're looking at the list. So this gets you A underscore sub and B underscore sub S slices. And then if A underscore sub is B underscore sub, count is count plus 1, and finally you return count. There are 3 places where these 2 strings are the same. There's the XX, and then there is the, what's the second one? Where's our second and third? There's the AA and there's the AZ. Okay? String match ABC with ABC. Obviously there's the AB and then there's the BC. String match ABC and AXC. There are no places where they have a string of length 2 in common. Okay, the last exercise. Stop the video. Understand the problem. Solve it. Then restart the video. Okay, you're back. I assume you've got a solution. And the trick is that you make a string consisting of all the lowercase and all the uppercase vowels. Initialize a count to 0. Then for every character in the string, if that character is in vowels, you add 1 to the count and you return the count. And here are the tests. A, B, C, D, E, F, there are 2 vowels. Uppercase A, B, C, D, E, F, there are also 2 vowels. Okay, so that ends our set of exercises.